Hey guys, welcome back to another episode of RTHD. Hey guys, welcome back to another episode of RTHD. Today we will be discussing megabits versus megabytes. So firstly, I'd like to welcome you and thank you so much for watching this video. This is actually a revised edition of the video. I would have created a video quite a while back, or about 3 years ago. So the quality wouldn't be that good and so forth. So I decided I'd do it over professionally as much as possible. And so I hope that you enjoy this quick tutorial. Hopefully I will not take too long explaining this. Before we begin, if you would just take one moment to kindly click that like button and that subscribe button so that you can get of course more videos similar to this and other tech videos. And don't forget also to hit that bell notification icon as well, because without that you won't be able to get any notifications when I come out with new content. So with that being said, thank you so much, and let's get into this short tutorial and explanation. Alright, so in this tutorial and explanation, how to video, I want to just make a quick overview, give you a quick overview of what's going to be happening. So what I will be explaining today is what is a bit, what is a byte, understanding how to convert bits into bytes, understanding conversely how to convert bytes back into bits, understanding kilo in terms of bits and bytes, understanding mega in terms of bits and bytes with the help of course with kilo, and understanding giga in terms of bits and bytes with the help of mega, because they are procedurally calculated, so it makes it very easy to go through those things. And with that being said, an important note about understanding internet bandwidth, download upload terms, and you'll actually be surprised when I explain that little part. And of course we'll end up with just a few comments and that will be it. So let's get into what is a bit. A bit is considered to be one of the smallest units of storage on a computer. Now nowadays of course we don't just have simple computers, we have phones that act as computers, and we have all sorts of different things. We had the PDA long ago, acts as a computer as well. We have TV boxes that acts like computers. So essentially a bit is applied to all these different technologies that work pretty much with anything that has a CPU in it. So a bit can store a binary representation, and what that means is that a bit is able to store one of two values. And usually a bit stores either a 0 or a 1, and think of it just like a light switch, the on and off, where off will be 0 and on will be 1. So that's simply what a bit is. It becomes more important as we go through what a byte is. So a byte is a set of 8 bits. As I said, each bit has a 0 or a 1, so that means that a byte has 8 of those switches, those zeros or ones basically. And a byte can be used to represent characters. For example, A, the letter A, might be this very long 8 character, 8 bit, basically 8 bits. So you're seeing 0, 0, 0, 0, 0, 0, 0, 1. And so that might be A, while B might be 0, 0, 0, 0, 0, 1, 0, if that makes any sense. In the example above, because we have 8 bits and each bit can store one of two values, the 0 or the 1, we see that each of these values that you see here, you see the 0, 0, 0, 0, 0, 0, 0, 0 part, we see that on the leftmost bit that is represented by 1 byte is actually 2 to the power of 7. Now think of this like permutations, right? Each bit here, for example, this rightmost bit, as you can see I have 2 to the power of 0 here. It means that if we only had 1 bit, forget all these other zeros, let's just say we had 1 bit, then there would only be 2 possible options right? 0 or 1. And so you put the base as 2 and then to the power of 0, and 2 to the power of 0 is actually 1. So we know that 1 bit can have up to 1 possible value. Now if we go to the second one from the right, see there's a 0. Consider that we had 2 bits, that 0 and that 1. Then it would mean that we actually have this 1. Remember this 1? There was 1 value here. So 1 bit could only have 1 value. But if we have 2 bits, it actually means that we would have to plus these 2 together. So we have a combination of actually 2 to the power of 1 plus 2 to the power of 0, which is actually 2 plus 1. So 2 bits could actually store up to 3 values. I hope that that makes sense. So essentially what's happening here is that a byte, of course, is 8 bits. And so we see that represented here. And this is where I calculated out all the possible values that 1 byte can actually store. Because essentially, even though it's 1 byte, it actually has 8 bits and pretty much more than 8 permutations. Each one of these represents some level of permutations. So we see that 1 byte can actually store 256 different values. And this is why bytes are usually used to represent characters, because if you look at your keyboard has many different characters. And so the representation of each character requires, of course, a different value. And this is how this essentially came about, and this is why I showed you the calculations of 256 possible permutations. So that's pretty much what a byte is. A byte is simply 8 bits. So let's just move on from there. It'll make a little more sense as we get a little bit deeper into it. Alright, so one of the most important things to probably understand in computing is how to convert bits to bytes. And it's very easy, so don't get frustrated, and hopefully my explanation won't also get you further frustrated. We know that 8 bits make up 1 byte, as you just saw in the previous slide. So if you need to convert bits into bytes, you simply divide by 8, because we already know 8 bits make up 1 byte. So if we have, let's say, 256 bits, then in order to get that converted into bytes, we just have to divide by 8. Isn't that really, really simple? Okay, cool. So let's move on again to converting bytes into bits, considering that we now understand that 8 bits equal to 1 byte. Then this should be the opposite of what we just said. So since 1 byte contains 8 bits, simply multiply by 8 when you have bytes and you want to convert it to bits. Example is like this. We saw the previous example where we had 256 bits, and if we wanted to convert it into bytes, we would have divided by 8. So let's make it a little bit different. Let's say that we had 32 bytes and we wanted to get the bits out of it. We would take that 32 bytes and we would multiply by 8 in order to get the bits. Pretty simple, right? Pretty cool, right? And this is, of course, you know, the basis of storage on most computerized devices. So you've just learned pretty much the core understanding of what computing is all about. So now that we understand bits, we understand bytes, we need to understand what kilo is in terms of bits and bytes. Now we already have a foundation of what kilo actually means. Usually kilo means 1000, but kilo in terms of computers is more accurately, it actually means 1024. And the reason for this is because most values are based on some level of binary operator. So you tend to not see plain 1000, but rather 2 to the power of something. And this is beside the point. This is just something that you just need to remember. So a kilobit is really 1024 bits. Now you could average it off as 1000, it's up to you, right? But accurately speaking, it is 1024 bits. So if we know that we have 1024 bits, then it would be very similar to calculate what kilobyte is, because kilobytes would just be 1024 bytes. So let's check this calculation out. So 1 kilobyte is actually 128 bytes. How did I get that? Well, we just went through the fundamental core of bits, bytes, and how many bits are in bytes, and how many bytes, how many bits make up a byte, right? So this is what this will explain here. So 1 kilobit is actually 128 bytes. How did I get that? All I did was I took the bits, as you can see here, I took the bits here. Because we have bits, we want to convert to bytes. All we have to do again is divide by 8, because we know that 1 byte has 8 bits. So in order to get bits into bytes, we just divide by 8. And the same thing, very similar here, is 1 kilobyte is actually 8,192 bits. How did I get that? Well, I took 1024 bytes, because we know that 1 kilobit is 1024 bytes. And then in order to get the bits, we actually have to multiply by 8, because we know that 1 byte is really 8 bits. And that's how we got 8,192 bits. Of course, you could pause this video and go through this stuff again, so that you understand it, but that's pretty much what it is. And so now we understand pretty much what kilobits and kilobytes are. And the reason why I would have explained that is because we want to head over to megabytes. And in order to understand megabytes, it is quite easier to understand kilobytes before we get to megabytes. So let's go over to megabytes. So the concept is similar for megabytes. 1 megabit is equal to 1024 kilobits. And that is, of course, this big number, which is 1,048,576. And how I got that was I took 1024 and I multiplied it by the kilobit, which is 1024 bits. So this is this part that you're seeing here. Excuse me. This part that you're seeing here is really 1 kilobit. So we took 1024. And we just multiplied it by that 1 kilobit, which I converted into bits here. And that's how we got everything in bits, 1 million, etc. in bits. And so a megabyte is very similar as well. We have 1024 kilobytes, right? Which is pretty much 1024 bytes, because that's kilobytes. And then we multiply it by 1024 again. That's all, and that's why we got the same value here for bytes. Therefore, we see that 1 megabit is actually 131,072 bytes. How did I get that? We simply took the bits value of what a megabit is. You see this value here. We took that and we divided it by 8 to get it into bytes. And that's how we got 131,072 bytes. And so 1 megabyte is actually 8,388,608 bits. Again, it sounds like a big value and it sounds confusing, but it isn't. All we did was we calculated as 1048,576 bytes. That would have been what 1 megabyte is in terms of bytes. And we just simply multiplied it by 8, because we know that 1 byte is 8 bits. So we just multiplied it out, and that's how we got this value. And the same concept happens with giga. So it's simply multiplying by 1024 every single time we go from kilobyte to megabyte, and then from megabyte to gigabyte. Isn't that simple? Yeah, it's not so difficult, right? So where is the complication? Well, the complication comes in with internet bandwidth speeds. For many of you, when you purchase your internet bandwidth speeds, your ISP really calls the terms in terms of bits, not bytes. And that's where a lot of people get that misconception that when they buy and they purchase their internet speeds, that they get it in bytes form, which is a bit misleading. The ISP sort of misleads you a little bit. It uses bits to make it sound like it's more than what it really should be. So let's get to the explanation here. The So internet bandwidth speeds are still represented in megabits per second, MB per second. Now some people of course have gigabits per second, but usually even in 2019 most people have megabits per second as opposed to gigabits per second. However, the most popular representation of storing data is actually megabytes, gigabytes, terabytes, petabytes, and so on. See the difference, bytes versus bits. So to better understand our upload and download rates, we should really convert the megabits per second into megabytes per second, because it's really megabytes is how we actually store the data on our hard drive. So when we download an MP3, when we're downloading pictures, videos, etc., we download that and we actually represent it in megabytes, not megabits. And that's where the problem comes in. We have speed as a different qualitative value compared to our actual storage on our computers, and that's why it becomes a little bit confusing. So it's better to understand our upload and download rates by really converting from bits into bytes. So for example, if we have a 10 megabit common B represents bit, 10 megabits per second upload and download connection, it really means we can download 10 megabits divided by 8. Remember, 1 byte is actually 8 bits. So in order to get 10 megabits converted into whatever the equivalent is in megabytes per second, we actually need to divide by 8. And so when we do that, we actually realize that it's a lot less. It's actually 1.25 megabytes per second that we are downloading at. And so that's why a lot of people have that confusion, because they're saying, oh, well, I pay for 10 megabytes per second, but it's really not 10 megabytes per second. It's actually 10 megabits per second, meaning that they can only download at roughly a megabyte per second. And so sometimes it looks like they're downloading slower, but it's not that they're downloading slow. It's just that it was a misconception and misunderstanding in terms of the terminology. And so that's pretty much what happens in terms of speeds, and that's why so many people complain and so forth. So just to recap, 1 bit is 1/8 of a byte, meaning 1 byte is equal to 8 bits, and that's really the core fundamental that you need to understand. If you have any comments and questions, let me know. I'd be happy to answer or create further details on any questions that you may have. You could just simply comment in this, in this video on YouTube, and from there I'll be sure to respond as soon as I can. Usually I respond within 24 hours or less, unless I'm working or whatever, but usually that's the time that you can expect a response from me. And if you have any other questions, if there's something else that you may be a bit confused about in terms of bits and bytes, please let me know. I'd love to answer these questions for you. With that being said, thank you so much for viewing. Once again, please like and subscribe for more. Hit that bell icon, and I'll see you guys again soon. Bye.